Go on to page 190 now, question number 136. Here's our participants. An orientation exercise must head at 2 and 97 for 1, 3, 2, 5 metres. And then they're going to turn on a bearing of 027 and travel another 1185. And the question says, what is the bearing and distance back to the start? Now, I'm going to have to try and draw a straight line down here, which is not easy. That's not bad. Now, it looks like a right angle in here, but you can't just assume that it is. You need to use a bit of maths to prove that. So I've drawn in a couple of north arrows, which of course should be parallel. They're heading on a bearing of 297. So there's a couple of things we know. If that's 180, then 297 minus 180 is 117 for this angle around here. We can use some parallel line rules. This angle down here should be alternate with that one there. There's my transversal cutting through. So that whole angle in there is 117. 117. And if you subtract 27 off that, I think you get left with 90 degrees, which is very cool because now we have a right angle triangle, so we can start solving the problem. And let's begin with the distance because it's the easiest part, using Pythagoras' theorem. This is the longest side because it's opposite the right angle, which makes it the hypotenuse. So that's going to equal the square root of 1185 squared plus, because we're looking for a longer side. Onto the calculator, remembering to put the brackets in. Doing some rounding, 1777.6. We're in metres, and I've rounded that correct to one decimal place. You could, of course, round it to a whole number too. You could 1778 to 4 significant figures. Right, now we want the bearing. What is the bearing and distance back to the start? The bearing and distance back to the start. So I think it wants that bearing in there. Right, well I can see that that's 27. I think there must be some parallel line angles in here we could work out as well. We are going to have to work out an angle. We could work out this one down in the corner here, or similarly we could work out the one at the top. If we work out this whole angle in here, subtract 27 gives us this bit, and then we can subtract it from 180. We could possibly do something similar down on this corner as well. Anyway, let's start by finding theta, which is this whole angle in here. Now that makes this the opposite side, opposite the angle, and this one would be adjacent. So tan theta, toa, equals the opposite side over the adjacent. Theta will equal tan to the minus 1 of that. Jumping on the calculator, we get 48.19247. I'm going to write all the digits down, and that's the whole angle. If we subtract 27, gives us an angle of 21.1924, etc. for this small angle in here. So the bearing will be 180 minus that. and we're getting 158.807, so rounding that to 3 sig figs, 159 degrees to 3 EZ for the bearing to get back to the start.